contest has started. Let's see. Okay, we're going to enter to the contest. Okay, let's open all of them one by one. So in the problem A, what they are saying, let's see, will be given input. So the first one will be the number of test cases. Each line will be containing a string, and each of the character will be either yes or no. Okay. Okay. Last Christmas, your friend Fernando gifted you a string S consisting of only character yes and y and n. You can repeatedly apply the following operation on S. Choose any two adjacent character and replace them with their logical wa. Okay. In each operation, you can choose an index I, remove the character S and insert a single y. Okay, so you can treat y as 1 and n as 0. Yeah. Note that after each operation, the length of S decreases by 1. Unfortunately, Fernando does not want you to come yes or no as yes. If relating to certain song, determine whether it is possible to reduce S to a single character by repeatedly applying the operation or combining two y's. Okay, so we can't combine two y's. Okay. So the S can go up to 100. So we can, at each step, we can iterate over all the S's multiple times, right? Yeah, we can. So it's pretty trivial. Let's do what they have just said. So you're going to take a string, you're going to input the string, and while the size of the string is greater than 1, what we're going to do, let's say we are able to decrease. So possible to decrease is true. No, let's say possible to decrease. Like we found any index adjacent to which is y and n. So if we are able to find this, then we'll change this flag to true. Yeah, we are going to do this each time. Let's say the new string is going to be 10, which is going to be empty. Trace of plus 1. Then we are going to set the flag to true. And we are going to add y to the temp. No. Let's see this one. Let's say 1 and 0. 1 is y and n is 0. 1 0 0 0. So no matter how many zeros are, they are going to all collapse to this one. 0 0 1 1. Then these two are going to form 1. But if there are more than one, then there is nothing we can do, right? Yeah. So we should just check if there are more than y, like one y, then the answer would be no. Otherwise, the answer would be yes. But why is it yes for this case? Let's see. For each operation, you can choose any index I, remove the character si, and then insert single n. Okay, we can insert single n. That is not an issue. A single y is also you can insert. No, we can't insert two y's. So we can only insert two. Okay, so whenever there are more than one y, we can say that okay, that should be no. Yeah, that is the approach. What happened? What is happening? No, yes, yes, no, yes, no, yes, no, yes, yes, no, yes, no, yes, yes. Solution.cpp. Choose file, competitive programming. let's read this one. Each test contain multiple test cases. The first line contain the number of test cases. The only line test cases contain the string R. It is guaranteed that Ri equal to S or U. Okay, so a string will be given that will be consisting of only characters S and U. The problem statement is saying that a string W consisting of lowercase Latin letter is called suspicious if and only if the following conditions hold. The letter S appears at least twice, and for every occurrence of the letter U, the two nearest occurrences of S are. Just a second. For every occurrence of the letter U, the two nearest occurrences of S. Same number of characters away from the U. After watching you finish string task, your friend gifted you string R. You can perform the following operation R. Okay, a string W consisting of lowercase Latin letter is. Okay, so it was the definition of suspicious string. Now we can perform on the string R either choose an index I and set the character at the ith position of the R string to S. Determine the minimum number of operations needed to make R suspicious. Okay, to make a string suspicious, there should be at least twice S, like S should be appeared twice. For every occurrence of the letter U, the nearest occurrences of S are the same number of characters away from U. For each of the U, how that could be possible? Two nearest occurrences of S. Let's see, this got submitted. Okay. Or let's just see the example test cases. Okay, we need to return the number of operations. Okay, let's take this example. In the first example, this is already suspicious because S appeared twice. Yeah, makes sense. In the second one, we are going to make this operation on index 1, 3 and 4. Okay. Alright, so we are going to make each of the U as S so that there should not be any U that has S on its left and right side that are at different distance. Yes, for each of the U. In the sixth test case, is not suspicious because two nearest S to only U are not two characters. So what they have done, okay, they have changed the U to S. Okay, okay. So basically what they are saying, they are saying that for all the U there is going to be S on both the bits left and right side. That should be in this same distance. If that is the case for each and every U in the string R, then this is called suspicious. Otherwise it is not. So such suspicious string can look like this. But if there are more number of U's, then it can never be suspicious, right? Because for this U it is true. This is 2 for both the cases, like both of the S are at distance 2. But for this U, this one is at 1 distance, this one is at 1, 2, 3 distance. Same for this U, one is at 1 unit of distance and another one is at 1, 2, 3 unit of distance. So there can never be two adjacent U, because for this case this U will have, this is at 1 unit and this one is 2 unit. So all the U will be separated by S. Then only we can say that okay, that is a suspicious string. Okay, that makes sense. Sus. Yeah. So we need to find each and every index where there are two adjacent U's. We need to remove the U's from that index. So if we try to traverse from the left, then is it always better to remove the middle one? What do you mean by that? Let's say S U S S U S U U U. No, let's say U U U. So if we try to iterate from here, then is it always better to remove this U and make it S, or remove this one and make this to S? For the first one, yeah, obviously this one is better. Like if there is any U at the leftmost index, then I immediately make it S. That is true. But then after that, if there are more number of U's, let's say this one is the example, S U U U S, then we are going to iterate from the left, and whenever we will see there is an U, we are not going to change this u, we are going to change this u. Why? Because we change this one as s, then we are going to always see that okay, we don't have to change this one. So yeah, that's how we are going to proceed. Let's see. Okay. Submit code not by. Let's take C++ 20. Compilation error. It was okay. Let's make another file. This is always going to be at least of one size, right? Okay, it is going to always be at least of 3 size. If s of 0 change this one to S. Now moving forward, this one and this one is used, so move this one to S. Now suppose, and the very end there is one U, then we should check for that one as well. Zero 3 0 3 3 1 1 2 6. Yeah, looks good to me. 'Okay, there are n children standing in a line where the niceness of the ice child is AI. The Santa is deciding which children belong to the nice list and which children belong to the naughty list. An integer x is initially set to 0. Santa will perform the following operation exactly n minus 1 times. Choose the first or second child in the line and remove them from the line. An integer x is initially set to 0. Why? Santa will perform some operation exactly n minus 1 time. Choose the first or second child in the line. Let W be the niceness of the chosen child. If the first child was chosen, add them to the nice list. Add W to X. If the second child was chosen, add them to the naughty list. Okay, subtract W from the X. So if I am adding a child, then it's nice. A child to naughty list, then its niceness is going to add up to its negative value. Okay, so I'll choose the least nice person and subtract that value from my x to get the x as my maximum number. Note that after all the operation, exactly one child remain unassigned to a list. Determine the maximum possible value of x that Santa. Okay, So yeah, makes sense. We need to make x as large as possible, and I can make x larger by adding all the negative number or close to negative numbers or the minimum number to the naughty list, and adding all the positive number or the larger number to its uh, nice list. Yeah, what do you call this? Yeah, nice list. Okay, makes sense. So I'll do that greedily, but but if there are two child that both of them are, yeah, this one is the example, then what am I supposed to do? Okay, let's take this one as an example. 5. So I'll add this to the naughty list. Yeah, so answer would be increased by 3. Answer, not answer, but x will be deducted by -3, which means it will add up by 3, which was at the beginning 0. Now it has been increased to 3. Now I have -2. I've removed -3, so I have 4, I have 10, I have -9. Now what I'll do, I will either I can take this child and add this to my nice list, or take this and subtract that to my naughty list. So removing 4 means reducing this x by 4, and adding this means removing, like, reducing this by 2. So the better choice would be take this one and decreasing this value by 2. Now I am left with 4, 10 and -9. Now I'll be taking 4 and add it to my nice list. So 3 minus 2 plus 4. Now again, from this 2, better choice would be to take this and add this to the nice list to get this 10, rather than adding this to a naughty list and adding 9, because adding 10 is always better than 9. So this will come up to be 15. Yeah, and 15 is the answer. But can I do this for all the cases without looking at the right, like without looking at what is in the right section? Maybe I can. Let's see. Let's say I have another example. 7 minus 1, 7 minus 6, minus 1 minus 8, minus 8. So adding this or subtracting this, both seems legit. But since I can always add this to my list, So a better choice would be subtracting this. So 0 minus minus 6, which will turns out to be 0 plus 6. Now I am left with 7 minus 1 minus 8 minus 8. Now adding this or subtracting this, subtracting this one is better or not, maybe not, maybe adding this one is better. No, subtracting this one is better for this case. Yeah, that I can say because I can see this element over here. But suppose if instead of minus 8 and minus 8 there would be 7 minus 1 minus 1 and minus 1, then in that case a better choice would be adding this 7, isn't it? Maybe. So after that I am going to add minus 1 to the answer. 0 plus 6 minus minus 1. Now I am left with 7 minus 8 and minus 8. Now I am going to deduct minus 8 from the answer. 0. Now let's calculate this. This is 15. Now I am left with 7 and minus 8. Now reducing this one is better or taking this one is better? Of course reducing this one is better. 15 minus minus of 8. Yeah, so the answer should be 23. No, looks like it should be 29. Okay, 29. 8 and 8 are 16. 16 plus 6 is 22 plus 7. Okay. Okay, this one is interesting. The last one. Six one eight eight. So value of x was 0 plus I need to decrease 6, otherwise 29 will not form. I am left with 7 minus 1 minus 8 and minus 8. I'm going to ignore this one and take this 7, because in the answer minus 1 was not taken, so that's why maybe they have got 29. 6 minus minus 1. Now I'm left with 7 minus 8 minus 8. Okay, that's no. I have taken 7, so that means I'm left with minus 1 minus 8 minus 8. Now I'm going to take minus 8, so it will be 7 plus 8. Now I'm left with minus 1 and minus 8. Now 15 minus minus 8. But 7. Maybe I did a mistake. 6. Okay, I should have taken 7. Yeah, 6 plus 7. It should be 13. 13 plus 8. It should be 21, and 21 plus 8. It should be 29. Okay, but how are they coming to this? That I'm going to skip this minus 1. This one is pretty interesting, I believe. So yeah, one thing is for sure that I'm going to take the largest and the smallest value. Whatever that comes near 0, I will try to ignore them as much as possible. So if I'm getting array like this, 4, 6, minus 9, minus 2, minus 6, 1, then I'll always try to ignore the one that is like that has an absolute value of the smallest number. So absolute value of 6 minus 6 is 6, absolute value of minus 2 is 2. So absolute value of x should be minimum, and I am going to ignore that x. 6. But is it going to happen always? 1 4 3 4. Let's take this one as example. 1 4 3 4. I have two choices. Suppose if I try to ignore 1 from the very beginning, then I am going to add this to my naughty list. That means x minus 4. So x was initially 0, so 0 minus 4 is minus 4. So I'm left with 1, 3 and 4. So all of them will come up as negative, and 1 will left. So 4, 3. Yeah, minus 11 would be the answer, but it is not the case, right? 8 is the answer. So what they have done something like this. They have taken 1, added it to the x. Now for 4, 3 and 4, what they have done, they have added 4 and they have added 3. That's how they got 8. And that's what they did. So greedily, maybe I can't do this. And since they are saying that okay, there can be at max 10 to the 5, so for each of the index in the array, minus 4 3 2 minus 4 2 3 minus 6. So for each of the array I am going to select that either I can add the ith element to x or subtract I plus 1th element from x. I have these two choices on what is going to be the state of this. Like if I add ith element, then what am I left with? Then I am left with the array from this I plus 1 to an index. And if I select this one, then I am left with this plus this. So if I am not adding this one, then that means that I have some no. How many people have solved this one? Let's see. Okay, many people have solved this one. So it should not be that hard. Now I can't use dp because if I select the second element, then how am I going to define this state? So this is very scattered way to select this element, skip this element, and select the remaining of the elements. Also, these elements can go up to 10 to the power 9. Otherwise, what I would have done, I would keep two variable, left and remaining. Like remaining would be the array, left would be the element. Now this value of left can also go very high. Okay, if I suppose if I take left as one element, no, actually the value of left could go very high, but the index of the left could be very less, right? Yeah. So that should work, maybe. Let's see. -2, -3, 4, 10, -9. Either take this or subtract this. If I take this, then my left will become 1. This is the 1, and I should select from 2. So answer would be -2 plus whatever this one gives. And if I subtract this one, then my answer would be minus of -3, because I'm going to deduct -3 with the x. So it will be +3 plus whatever this one returns. The time complexity will be, there are two states of the TP. One is left and one is right. Like one is left, one is remaining. And they can go as big as 10 to the 5. And this is 10 to the 10, which is bigger than 10 to the 8. Still, let's try this one. And what is going to be the base case? The base case is going to be when So when the remaining value would go to n, so when it will go to n, we'll say return 0. Yeah. Take left means adding the left child niceness to x. VL plus f of, now left, the new value of left will be remaining, and remaining will be increased by 1. And take right child's naughtiness means f of L, remaining will be increased by 1. And the value will be reduced to the niceness of the remaining child. Yeah. And the base case will be what? Remaining is n, then return 0. Yeah, we'll use the DPRA later. Let's see this for these test cases. How this are working. Okay, I'm not printing anything. Three, 8, 4, 15. This minus 129. Looks like it is working, but not sure if I use DPA how much it will. Oh. Now we need to put a value over here that can't go beyond this thing. So 10 to the 9 and 10 to the 5. If I multiply both of them, 10 to the 14, yeah, and comma minus naught. What should I write over here? Minus infinity. Is it working? 8 4 15. Yeah, it is working, but not sure how much it will work. This will not work. This will give a space limit exit. Memory limit, sorry, my bad. Okay, let's see the D as well. Each test contain multiple test cases. The first line contain D to integer nm. There are array of size n, the initial attack, and the health values of the elf. N is the number of elf and m is the number of elves to be left alive. M is always going to be lesser than equal to n. So the number of elves that is going to be alive is always going to be less than n. Yeah, makes sense. The second line contain an integer. The initial attack and health value. Okay, so both of them is represented by AI. So all the AI is going to be distinct. Okay. Franklin is plotting a Christmas attack where he casts spell message on village of elves. Mass history, Hearthstone. There are n elves numbered from 1 to n, where elf I has a health value of HI and attack value of AI. Okay, there is going to be one array. So what is health HI? Okay, initially health I and attack I both of them are same, and all AI are distinct. If I alive if only if health is positive. When Frank then cast Mars Hysteria, which is a spell, the following process is repeated. Choose a pair of distinct elf X and Y, and the health of this 12 should be greater than 0, and this elf was not supposed to be attacked before. If no such pair exists, terminate the process. And then what is going to happen? Then elf X attack elf Y, decreasing HY by AX. Okay. Additionally, due to recoil, HX is decreased by AY. HY is going to get decreased by AX. And HS is decreased by AY. Okay, so both of them are going to decreased by other person's attack point. Note that AX and AY remain unchanged. Okay, health might decrease, but the attack point will not change. The process will repeat until it is impossible to choose a valid pair of health. Okay. HY minus AX, HX minus AY. And this process will continue until there is no elf that has not attacked before. So we can choose one elf multiple times, but with that elf we should choose another unique elf that has not been attacked before. Given an integer m, construct a valid sequence of attacks such that exactly m elves are alive when the process ends, or determine that no sequence exists. Yeah, this is giving memory limit exceeded. So we can't use DB, maybe I need to put greedy approach. One more thing that we can do is that select each of the I from 1 to n, like from 0 to n minus 1, and say that okay, this is going to be the last one standing. But even if we say that it's a 1, 2, minus 3, minus 4, 5, 6. Suppose 5 is the element, then there can be multiple combinations, right? We can either add this or subtract this. Yeah, let's try this one. Yeah, in that case also multiple variation might happen. So for each of the element, by looking at the right, we can say either choose this one or this one. But how? Okay, choosing the left one means I am just swapping the arrangement. Like if this was the number that was supposed to come eventually to the naughty list, like this was supposed to come as the second child. If I am choosing this one, no, then also this might come. That is not the case. So it will not add any effect to its right. Is that the case? 4 10 minus 10. Suppose it was like this: deduct 2 or deduct 2. Then it's always better to deduct this 2, because I'm getting this as a positive integer. Now let's say 1, 1. This is better. So I think, yeah, that was it for the video. See you in the next one.